What I haven't mentioned so far is how we get these numbers here and these numbers here. And the way to do that is by generating random numbers, because what we know is that we have some variability on the time that Bob spends on producing or working on every part. And the same with Ray. So what we have here is a generation of random numbers. Okay, these are random numbers, and these are random numbers. And according to these values here, we go and get what is the value corresponding to the time for Bob and for Ray. So let's see this very fast in this sheet we have here. This is our input data, and we have as many rows as intervals, okay? And what we have here is the time corresponding the mean value, okay, or the center point of every interval here. We have 10 for this interval, 20, 30, and so on, okay? And we have values for Bob and for Ray. And what we have here is the frequency observed for each interval. So 4 times we saw values within this interval, 6 times we saw values within this other interval, and so on. And this is the accumulated frequency, which means that we saw 4 times the value which was within this interval, 10 times we saw observations of tasks within this interval or this interval. We saw 20 times, which is 10 plus 6 plus 4 times observation within these 3 intervals, and so on. And finally, we saw that all 100 observations were within one of these intervals. Okay. So what we have here is intervals for random numbers. So when we produce a random number, if it's equal or less than 4, okay, we pick a value within this interval, and in particular, we'll get 10. If the value is somewhere between 4 and 10, okay, we'll get this value here, and so on. And that is the way that the probability of having elements of this interval picked according to this frequency is satisfied. So what we are doing here is we're translating these frequencies into probabilities, because we are assuming that the probability of Bob spending the time corresponding to each interval will be consistent with what we observed in the past. So we are turning frequencies into probabilities. And this is consistent with the input data table I showed before. So what we have here is a third sheet where this, I didn't mention it, is everything fixed. Okay, these random numbers are fixed. And we can have an automatic calculation sheet like the one we have here, where we have this, this is in Spanish, we're rounding a random number between 0 and 100. So what we have here is a lookup function that goes to this input data sheet to find the value according to the random number that Excel generated. So if I press F9, which is the way to update values, I'm getting different values for these working times, okay? And according to what I get here, everything is also calculated, and we have the ending times, the waiting times, and the same for Ray. And eventually we have the total working time for Bob and the total working time for Ray, or on average that those same values per part, because we just have to divide by 10. So one thing we might ask ourselves is whether this is representative of how our system works. That might be the case, or it might not be the case. So the way to do that in a simulation, because typically, and I'll explain that further later, we have variability, is to run or to do several replications, which is executing or doing the calculation several times and getting average, at least average values for whatever we're interested in. So in this case, let's take a look at Bob. We have a utilization rate of 80%. Now it's 87, 77, 86, 77, 85. So what we could do is get all those values and get the average of those to have an estimate of what is the expected utilization rate of Bob, and the same for Ray, and the same for any other KPI we want to explore. So this example shows that in discrete event simulation, what we do is reproduce in every detail the behavior, in every relevant detail, the behavior of our system, and we do replications. And every replication corresponds to a possible behavior of our system. We are not sure if those values we have here are those we're going to encounter in our real system. But if we press F9 several times, on average, we will have a very good representation of what our system will behave like. Okay? So I will present another example, and finally I will highlight which are the features of discrete event simulation.